So I think time is already. We can start.
Okay, Professor, welcome back to our course. And I think we don't delay your time, and time is yours. I will stop my share screen.
So now we can start. You right? Professor Harry.
Yeah, hello.
So I can start it, right?
Wait a moment. We will check the participant. Yes, our student from TK 5096 is already complete. Mr. Pian, I also invite KKK and his co-collaborator to join this one also. And I think we have to have a break in between to give a chance from the audience, from the student to ask any question in the middle of your lecture and at the end of the lecture.
Okay, I will set a break for discussing or just for a list.
Yeah.
And if I cannot finish all the slides, I will continue the next literature
That's
lecture.
it. That's
Yeah.
it. Yeah. Not necessary to finish all the material, but if there is a question, if there is discussion, let the student to do that. Yeah. Okay, thank you. Now it is 2 minutes past 3 o'clock in Indonesian time. Please, 3 minutes more. We wait for 3 minutes more.
Okay. So thank you, Professor Harry. And I have some friends also attend this lecture from Thailand. Dr. EKK is here, I think. So you are welcome.
I don't know how to see that.
Just welcome. As the last two class, I already share the development of waste to energy in China. You already have a general idea about the waste to energy. And the second course, I introduce the sampling and analyze because before we design a boiler or incinerator, we have to understand the character of the MSW, how much the moisture content, how much the volatile ash, also the heat value is very important for your calculation and for your design. And today I will introduce the incineration technology. This is the core of the WTE system. So hope you enjoy. For WTE system, actually it consists of some section or parts, including the incineration, heat exchanger, pollution control, and turbines, and some other parts. So, but for for the waste to energy plant compared to the normal or fossil, such like a coal power plant, what's the difference? Is the incineration. So I will focus on the introduction of different incinerator, including the CFB and the grit, right? So for this is two kind of the incinerator, grit and the CFB. These two figures I already showed the first class. For the equipment of W2E system, including we need to have a tipping hole, just store for the refuse or just called the MSW, and we have the incinerator and for boiler. Actually, incinerator is for combustion, boiler is for heat exchanger, and also we will have the bag filter, carbon injector, and spray for acid removal, and also some fans. So we focus on the incinerator. The position is here. After the tipping hole, the MSW will feed into the incinerator. After burning the flue gas will through the chamber or heat change channel to produce steam. And this is the thermodynamic of WTE. So this is a incinerator, steam produced in the boiler and drive the steam turbine. For the coal power plant, usually we will have the heater, but for the WTE, the heater is not normal because the pressure, even the initial or refresh steam, the temperature pressure is not high enough. So after work in the steam turbine, the pressure is not enough high. So usually only at a high pressure steam turbine at a low temperature steam turbine, not a reheater or regenerator. And of the gas steam turbine, will condenser, and we also have the excuse just save the heat from the flue gas. Economic actually is economic, and pump it then make cycles. For the efficiency of WTE, actually many participators will very concerned how much the efficiency of waste to energy, that means 1 ton, how much electricity can produce. Actually, it mainly depend on the steam turbine, what's the temperature and what's the pressure of your steam turbine. So with the increase of temperature and pressure will, improve the electric production efficiency. So you can see here, if just the middle temperature, middle pressure, roughly 20%, then maximum can up to 30%. So this is the regulations. And here also we usually in the industrial we call the incinerator or the steam turbine is a medium temperature, middle pressure, or middle temperature, high pressure. Of course, the optimum is the high temperature, high pressure. But usually for steam for WTE is impossible. So use the middle temperature and high pressure. It will be the maximum setting and percent. So the medium temperature such like 450 centigrade and high pressure 30.7 megapascal. Combine the reheating, the efficiency can up to 31%. In China, the industrial efficiency roughly is 25%. So it's similar all incinerator. For incineration, actually, as I mentioned in the first lecture, just never mind what kind of fuel, all is combustion. So MSW, biomass, we need oxygen. We need supply enough oxygen for the combustion, and will produce or emit heat. So this is a chemical process. During the incinerator design, you also should thinking how to supply the air. So we have primary air and secondary air. So never mind the CFB or grid. We divide primary air and the secondary air. For the grid, for the incinerator, two kind of incinerator typical in WTE include the grid furnace or CFB, cycle fluidized bed. So the grid furnace just like the layer combustion, and for CFB actually like space combustion because the fire is in the space, and for the grid, the combustion MSW is on the bed of grid. And actually, there is the third incinerator called rotary kiln, but it's not for MSW. At least in China, we don't use this one for MSW. It's only for hazardous waste, such like industrial waste, hospital waste, some waste from the chemical factories. and the scale is not much larger as the MSW incinerator. So usually it's 50 to 100 tons per day, and have two stages. First, rotor killing, and second, combustion. And this also we call this, we can call it rotary grid. So just the name. So for the typical incinerator for MSW is grid incinerator and CFB. I will separately introduce. First is grid incinerator. After grid, I will introduce CFB. So this is overview of the grid incineration. So as mentioned, that tipping hole, carry, and feeder. This is the grid. Then this is the boiler and the heat exchanger, or we call the evaporation area. And this is for the heating air, for primary air heating. And this is pollution controls. And this is a steam turbine. For if we go to like how to say the mechanism, or go to the fundamental, it is here. So we need air, right? The primary air actually is from the MSW tipping hole. So the odor or the smell will sucked by the fire and inject to the incinerator. And actually during the startup, or when the MSW is not stable to wet, we also will use gasoline to ignite or just support the combustion for make the incineration is stable. The temperature is high over 150 centigrades. So this is the gasoline, and the second air is a feeder on the top of the bed, and the primary air is from the under or below the grid. And after incineration, the hot flue gas will follow through the superheater economies. So this is the inside of the grid. You can watch the fire is very strong, right? And this is the west in the tipping hole. So the MSW is decomposed on the bed of the grid. So we can how to say simulate what happened on the grid. So the west is feeding from the left, then it will drain, pyrolysis, gasification, or combustion. And here is the reduce CO2 to CO, or produce char, and at the end will produce ash, or we call it slag. So this is the composition of the flue gas. The CO2 is in the middle, or in this area is highest. So alpha means the excess air ratio. So alpha larger than 1 means the air is more. Alpha smaller than 1 means that the air or oxygen is not enough. Actually means it's consumed or converted by the combustions. And this is the vertical layer. So at the surface is the flame, and the new fuels, reduction, oxidation, ash, and grit. And here is the same, the vertical layer. So in different depths and happen different reactions. Of course, the reaction at the different lengths and different depths is different. So it's a little complex. And actually, the grid for MSW is developed from the pulverized coal, so coal powder. So usually at the beginning we use the chain coal, so a chain grid, and with developing, we especially for biomass, we use vibrating grid, and also some factory will use rotary grid. This is usually or at the beginning is not for MSW, it's for coal. But with the development, we correct the grid for MSW. We call it as reciprocation. Excuse me, reciprocating grid for MSW. And I mean the movement is how to say frequently, so forward back. So and the combustion reaction is as same as mentioned in the previous slides. For the reciprocating grid, is mostly widely used in WTE plant, and grid is easy to operate, especially compared to CFB. Grid is easy operator. So this is fine. And this is the structure of the grid. So this looks huge, right? So usually the length is fixed for the same company or same factory. The vendors can be modified depending on the capacity, such like 300 ton per day, or 500 ton per day, or 800 ton per day. The length is the same. They just add more model, one layer or two layer or three layer. So this is the typical reciprocating grid. For the grid also have different kind depending on the install or depending on the movement directions. So we have the this is a horizontal grid. So you can see the west on the grid is horizontal, and all the movement direction is forward for the as follow of the MSW, and this is counter. So the different grid piece or bar, the direction is count, and this is reverse. What means reverse? Reverse means the move of the grid is reverse as the follow of MSW. So MSW go down, but the grid will go up or this direction. So this we call the reverse and the rotating. Structure of reciprocating grid. So all the different capacity or the whole reciprocating grid is consist of one piece of the grid. So this is the piece. So the grid piece, or we call the grid plate, is divided to fixed or movable. So movable. So this is movable. This is fixed grid, and so this different kind. And the grid move distance usually is 30 to 100 millimeter, and for frequency is 1 to 5 times per minute or less, even 1 times 5 minutes. And the MSW thickness on the grid is 500 to 1000 millimeter. That means on the grid, on the feeder and the beginning, so this position, and the thickness will reduce. And the grid ventilation air ratio is 7 to 12%. It means this is for air follow through. So ventilation. The horizontal reciprocating grid have two kinds. One kind is the MSW is on horizontal level, so just like this, horizontal, and another the fixed or no the greater bar move horizontal. So these two can we also can both can call horizontal and horizontal reciprocating grid. So you can see this hole is for air, and this also is the greater plate. And the horizontal grid is of modular design. The length of each modular is fixed, but the widths may vary according to the specific requirement, means the capacity or such like other requirement. And each modular has its own driver and supply of air, both of which can be controlled separately. And this is called reverse reciprocating grid. So you can watch here. The movement of the grid is go to upside, but the MSW will go to the downside. The incline, or we call the tilt angle, is 26 centigrade. This is from Martin company. Different company, the design is a little difference. Usually, yes, we can say is 20 to 30 degree, or yes, 24 to 26 degree of the angle. And the each means this one monolithic grid is 1.5 to 2 meters, and here I have 3, so it's roughly 5 to 6 meters of the width, and the length usually is 10 meter. So the flame temperature can hold stand for 1200 centigrade, means the grid can work under these high temperature conditions. And you see a person stand here to check, and this you can also see here some holes, right? This hose is for the second air, and also there are some gate, right? This gate is for checking. So during operation, you should check the combustion is stable, or also will fix or install camera here to monitor the combustions. And this is the reverse reciprocating grid from different company, the CT20 grid. So the incline angle is 24 degree. The movement is once every 5 minutes. The grid is cooled by primary air. So primary air is from the bottom of the not bottom on the grid. So from these directions, and from here you also can see the slag discharge. So this looks like the weight discharge. That means here is water. The slag drop down, then it will cool down. Another is will seal this output, so the flue gas will not go out, or the air cannot enter from the slag output. This is important. Usually use the wet slag is easy operation, but also some company use the dry slag discharge. And this is a dynamic of the reverse reciprocating grid. So if we start the grid movement, the MSW will drop down slowly by gravity. And of course, the grid push is from like this direction, from the right hand to the left hand and go up. So push effect of move grid step. So finally, the core effector, gravity and the push effector will mix of the waste. So this will promoting the combustion and the mixtures. This is the rotating grid. So looks very simple, is right? Actually, here is the capacity roughly is 7 to 40 ton per hour is already very huge, right? So 150 ton per day to 900 ton per day can in the range, and the LHV can 8 to 13.5 megajoule over kg. So roughly is 1,700 kcal per kilogram to 3,000 or less, 2,500 kcal per kilogram, and the width is 2.5 to 7.5. So it depends on the capacity. If the capacity is small, the width is narrow, but the length is fixed. So this direction, the length is fixed. Never mind the capacity or the change is very little. So the length is 10.5 meters. Each setup have 5 to 7 royal. So here is 6 royal, and the angle is 20 to 30 degrees. So if 30, that means maybe we need a length of the or longer uh, uh, of the incinerator because the resistance time will reduce. So the length and the angle will decide the resistance of MSW on the grid. Usually it is necessary the resistance time of MSW on the grid is 1.5 hour to 3 hours. So it stay long time. But for CMB, maybe only some minutes. So this is a significant difference. And this is vibrating grid. So vibrating grid is not commonly or widely used in China. So this is the mechanism. There's a spring, so you use the motor to push down. Just also is the effect is for mixture of the MSW and promoting the combustions. And actually, for the real design or industrial application, the design is very complex. I just introduced the basic movement. So actually, we have the multi-movement grid. So one grid have different move, including we call it as horizontal or reverse or rotary. So this is a horizontal, and this is a vertical motion, and the last stage is rotary. So the grid control system will separate the transport. So transport is for horizontal movement, steer mix, and for the ventilation, so will help for the air mix with the MSW. So stealing is for hot and cool MSW mix together, but for vertical is for help the air mix MSW. Both will promote combustion, completing incineration. So swaying grid is used for Western mix. So what here? Yes, during the application, the engineer will find some new problem or thinking out a new idea to promoting the incineration. So diode device, or we call it the blade, can break clumber of MSW. Sometimes the MSW is how to say mixed together or catch together is not easy to separate. So use the diode device. Use this one, cutter, or just separate the huge part of the MSW. So promoting steer and combustions. And also we have the multi-stage grid. So previous I just say different movement, right? And we also can have use combine different movement grid, reverse or horizontal or rotary, but in the real incinerator also developed the multi-stage grid. What means multi-stage grid? So we have some stage. There are the different heat. First stage, the second stage, right? So the waste will drop from the high grade stage to the lowest stage. Then just like jumping will also helpful for mix the MSW. This is helpful for incineration. So grid can be divided into multi-stage. Each stage has its own moving style, such like for use for driving unit. One is in the drying stage, the second is in the combustion stage, and another in burnout stage. Or actually have one more is for feeding stage. Control the waste and dust layer thickness through the speed adjuster of each independent drive unit. So the speed can difference, such like for the burnout, we can move fast. But for the drying, okay, the frequency should be lower. So here for drying. Here, just diagram. So this is a feed position. MSB will feed from the left, then drop down. Okay, so mix one time. Then use this grid to mix to dry. And here have a difference of the heat. So we'll drop down again. So mix the MSW then like this. So this one is burnt out. So this is the inside of the MSW, the grid. So actually here is the feeder. So go down. So you can watch here. So this is the feeder, first stage, second stage, and the third stage. And actually from this picture, you also can find let's have 1, 2, 3, 4, 5, or even 6 zone. This is how to say air hoop for primary air. So we divide or separate the hoop, then we can control the air ratio, different hoop, different stage. We supply different amount of the airs. This is a case designed by Chinese company Weiming Wenzhou in our province. So they use the two stage, and the first stage the movement is backward or reverse, and the second stage is forward. So just this direction, and this one is this direction. So from here, the first stage, the resistance time is very longer. It will help for drying pyrolysis and incineration. And here, because burnout, the bottom ash can quickly finish the burnout. So the resistance time will very short. So just quickly, how to say, discharge. The capacity can be 160 ton per day to 600 ton per day, and the steam pressure is 3.8 to 4 megapar, and steam temperature is 400 to 450 centigrades. The flue gas temperature is 220. So I have to explain what means flue gas. Flue gas temperature, that means after all the heat exchanger, usually is after the air heater or after economics. And the feeding water is 130 to 140. So this is also designed or depend on the economics. So the ignition loss of slug smaller than 5%, it will be used to calculate the combustion or incineration efficiency. And this is the primary air supply. So because primary air is for combustion or for the first Paris gasification, but also it is used to cool down the grid. As you know, the grid, the maximum temperature on the grid can over 1000. So if we not cool down, the grid will closing, right? Will wear very quickly. So we have cool down. So here have 6 zone, and the air from the below or under the grid then go out, blow out from some holes. So this is the hoop, the primary air hoop. So you can see the air from the bottom and the fire is here. And usually the primary air is heated from such like 180 to 220 centigrade for primary air. But for the secondary air, usually is without preheating, at least in China. But now more and more company, they started to thinking use the hot secondary air. So because the hot secondary air will be helpful for increase the incineration temperature, will how to say can reduce the emissions, and how to say will increase the parameter of the steam. So the efficiency will be increased. But of course, there are many challenges, especially for the closings. For coal power plant, is no problem. But for the MSW, as we know, their sulfur chlorine content is higher in the MSW. So if temperature is higher, the closing also is very serious. So this is the challenge. But anyway, or how to say, some factories start thinking this to design high temperature air combustion, but not common applied in the industry, maybe in the future. For the grid, we have to cool down. Most of the grid is cooled down by air, just by primary air. The design, the manufacture is simple, right? It just use the primary air. But when the MSW heat value is very higher, maybe air heating, air cooling is not enough, cannot efficiently cool down the grid. So we have used the water cool or grid plate. So this is water cool and this is air cool. For the air cool, have many things to heat exchanger, or we use is convection or conduction, right? Will promote the heat exchanger. For the feature of water cool have many advantages, such as large variation in fuel composition and heating values, suitable for higher LHV, waste up to 20 megajoule per kilogram. For air cooling is impossible. And another is operation and low excess air, because if you use air cooling, your primary air is not only depend on the combustion requirement, also depend on the cooling requirement. So you can you just do a balance. You cannot very well control the excess air. Low excess air will reduce the heat discharge by flue gas. So because the flue gas is less, the waste heat is less. So this is will increase the efficiency. Of course, the cost is higher, the investment is higher, the system is complex. So this is a water cooling system. You can see they have a tank. This tank is for liquid water. Water coming, right? Go to the fixed grid bar or the movable grid bar. Then the hot water come back for heat exchange, means cool down, then cycles. So this is for the water cooling system for grid complex. But for air cooling, we just use primary air to cool the grid. This is a company from Denmark. Their water, excuse me, this is air cool. So have some parameters, and this company also have the water cooling grid. So we call it a Baba Coke, right? So the LHV or high calorific waste up to 25 megajoule per kilogram. So and it's possible to for biomass cool value will reduce the air exit ratio or optimal primary air additions. So this is the advantage for water cooling. And this is a piece or the bar air cool. And this is the water cool. The grid surface cooling is independent so that the air can be, this is, excuse me, it can be added and adjusted for optimum combustion. Actually, some company, they can design, you can change, such like when the LHV of waste is lower, they use air cool, and when your MSW heat value is increased, you can change your grid piece to water cool. And this is one grid, but two style. The first three is water cool, and last one, so four, or here the third use air cool sections. So it's very special, maybe because this area is the combustion area and this is the burnout area. So the temperature is a little lower compared to the middle. And this, yes, some company also increase the character of the grid, even say Martin refers acting grid even when heating values as very high is not necessary to cool. So, but it's not common, maybe just some idea. And grid bar cooling, the company has both an air-cooled and water-cooled version of the grid technology. The design are interchangeable. What means interchangeable? Means you use their product, their machine, they can change your cool style. So at the beginning, you install air cool grid, but 5 years later or 10 years later, the heat value increased. Means the feeder of your waste is become better. Then they can change the grid piece to the water cool. So it's very good. Of course, the cost is higher. So for some detail, the grid bar cooling, because during the incineration, the surface of the grid is very high temperature. So expansion of the steel is inevitable. So we should set some gap between the piece to piece for the expansions. And this is for the maintenance. Actually, the grid also need maintenance, as I mentioned, for Chinese incinerator. Usually 1 year we should spend 1 month for maintenance. So the operation hour is 8,000 for the incinerator. So here mentioned more wear and deformation in the second and third destructor, and greater replace will above, it means a higher 1 to third. So means 30% of grade need to replace every year. The grid furnace structure, because we just mentioned the grid, and the grid should be combined with the furnace or with the boiler. They have 3 styles. Oh, how can I remove this? So this is counter follow, and this is close follow, and this is uni follow. So you can see the furnace position in the front of the grid, in the middle of the grid, and in the end of the grid. So this is a different kind, right? So here the flue gas will helpful for the drying, right? And this is helpful for combustion, maybe is for burnout. So different company, the design concept is different. From this to DCS, you can see from the left operations screen, you can see this is the county follow. So the furnace installed at the beginning and the front of the grid. And the uni follow is here. The furnace installed on the end of the grid. So this is the 2 kind. For the greater incineration, we also still need how to combine the boiler, combine the heat exchanger with the grid. So we have 3 kind or 2 kind or layout of the grid furnace. We call this a vertical layout and horizontal layout. So this is vertical layout. This is the horizontal layout, and we call pure horizontal. And this is a pine type. So because just like a pine, right? So 3 kind. So what's the difference? Yeah, it's easily to recognize for yourself. For the vertical, yes, this position is great. So less space usage and material usage than horizontal layer. So because all the heat exchanger on the above of the grid, then can save the land and save the end. 3 vertical film type water will change. So here, 1, 2, 3. And the last one is vertical steel flow or flow channel. So all the heat exchanger or evaporator is installed in verticals. So in the third channel from top to the bottom, scarcely first stage stream generator, high temperature superheater. So here high temperature and low temperature and the second stage generator. In the fourth, this is third channel, orange economics. So it's for heating feed water. And the last is a preliminary air heater. This is a horizontal, pure horizontal. So you can see we need a large lander. So because all the heat exchanger is installed horizontals. So here is grid, furnace, flue gas blows through all the heat exchangers. So, and we also need a soot blow, or because the ash is easily block on the heat exchangers. So high temperature and low temperature and this is economizer, so for heating water, and this is pi. So because we want to recover the energy as possible, as high as possible. So after the horizontal heat exchanger, we also install verticals. So this is vertical, and this is great. So it's a pi style. We can make compare between among the three styles. So for air, vertical is small. For horizontal is larger. For horizontal pi style is larger. But for the self-clean capacity, vertical is poor and horizontal is good. Means will how to say easily blow the ash from the heat exchanger surface. Horizontal is better. Now in China, I think the pi style is more and more common. Here I introduce some case of the great applications. So actually this is very famous. When I'm student, I already learned the Austral Vienna WTE plant. So because the building is very beautiful and is close to the citizen, how to say, house. But as because it's built very earlier, so the parameter is not high. So you can see the temperature and pressure only 34 bar and 245 centigrade. So the efficiency is very lower, if less 20 percentage, only 15 percentage. But this is developing step by step. You can see here, and the great length and the width is 7.5 meter and 4.6 meters. This is the second in Denmark. The gross electrical efficiency is 27%. Is quite good. And here I'll show all the temperature distributions. So from here you can see the primary air is 145 centigrade. From here we can see the flue gas temperature is 180. And the temperature pressure already increased from the Vienna. So the temperature pressure is 422 centigrade and the pressure is 48 bar. The output is 17.9 megawatt. So it's quite huge. The length and the width is 9.9 meter to 9.1 meter width and length. And the capacity is 20 ton per day. So roughly yes 900 yes 900 ton 20 ton per hour, 500 ton per day. Excuse me, 500 pound per day. So please keep a mind or an idea roughly 500 ton per day. The great scale is 10 meter width and 10 meter length. So 10 to 10 square for the 500 capacity, 500 ton per day. This is a very common capacity or scale in China for one incinerator. One plate maybe 2,000 or 3,000, but one incinerator usually is 500 to 700. This is the hot grate, have horizontal and vertical movement. And this style is China in how to say China grate, developed by F. Brett. So this is Suzhou I faced here two times. Have 3-stage projector and 3 how to say accelerator. This is accelerator. The capacity per year, yeah, here at the loss of slug ignition is less 3%, means the combustion organization is quite good. For dry stage is the first and second unit. So first and second. Burn out is the final unit. This is for 500 tons per day, the arrangement. So this is how to say transfer arrangement. So 1, 2, 3, 4. So one actually is 1 unit. So we just combine 4 units. This is length, this is width. And for each, this is for 1, right? Each unit we can have different stage. And this is a control screen, so you can watch a temperature. Yeah, also here is some temperature distributions. This is horizontal, and here also is horizontal. Horizontal structures, as mentioned. And this is Chongqing. We import a grate from Martin company and install in Chongqing, Tongxing. The capacity is two incinerator, each is 600 tons per day. So totally is 1,200 tons per day. And this is the parameter of the first reciprocating grate. So LHV is 1,000 kilo cal to 2,000 kilocal KCL. And the recent time of MSW on the grid is 1.5 to 2.5 hours. A turbine is here. So from here, you can see usually in China, 500 tons per day, the generator capacity or the turbine capacity is 10 to 12 megawatt. And the incline angle is 24. So usually 24 or 26. We can say the in range is 20 to 30 degree of the incline angles for grid. So this part is for greater introduction. So we can have a break, and if you have question, we can discuss. Professor Harry.
Yeah, thank you, Prof. Mian. So this is a time for question and answer. If anyone want to ask question or make a comment, please just raise your hand and then I will call of you. Anybody? I see Pak Soleh from Indonesia Power, Pak Adi from University of Indonesia, maybe your friend, you or your friend or your students ask something to Prof. Mian, please. This is a time for question and answer for 10 minutes, about 10 minutes, before we continue to another subtopic. Teman-teman lain, tidak hanya Pak Soleh dan Pak Adi yang sudah saya sebut namanya, di sini ada friend from University of Lampung, Unila, bisa bertanya, silakan bahasa Indonesia juga boleh, nanti saya terjemahkan, dan terutama mahasiswa TK 5069, konversi termal biomassa, silakan. Biasanya ada yang bertanya siapa itu vektor, ada siapa lagi. Silakan.
Izin Pak Heri duluan, nggih.
Ya, monggo silakan sebut nama, perkenalkan ke Prof. Mian dulu namanya.
Ya, baik. Good afternoon, Mr. Yan and Pak Heri and other college ITB. introduce myself. My name is Muhammad Soleh from Indonesia Power. I am operating from a power generation power plant. So mostly we handle a coal power plant, but recently we are also uh, you know experimenting in biomass co-firing, especially from waste base, RDF or SRF, to be co-firing in a power plant. My question is, you from until these slides, you explained about the system, mostly about the grade configuration, reverse grade, vertical grade, vibrating grade, and so on. But especially from my um, several, uh, I need I need to be understand about the process, prior to enter the grade itself. So mostly the waste is Indonesia is household waste is like high moisture, wet, and mixed, with other like uncombustible materials, biomass or plastics, and so on. So how the process prior to enter, is it already say a sorting or another process or drying or so on? So when entering the grades is already ready to be combusted, ready to be burned, and easily will be burned uh, in the in the grades. So I think, and then number two, how will we manage the emission and the emission and side products, say ash and so on. But mostly the side product of a combustion is the gas and the ash. We haven't seen in the presentation, but I don't know. Perhaps in the will be present in other. But I think that's my two question for now. Thank you, Pak.
Okay.
Thank you, Pak Soleh. And Prof. Mian, go on.
Thank you, Mr. Sola. Your question actually about the West, I already introduced last lecture. So the situation is quite similar in China and in MSW because the waste sorting is not as good, right, in Indonesia and in China. But for the combustion, it is no problem. Of course, if we make sorting produce RDF or SRF, it will helpful for combustion. But for how to say the present MSW is no problem for combustion and incineration. For the technology, actually in China, the historic, we also have some how the development stage by stage. At the beginning, we import the grit from developed countries, from Germany or Japan. It cannot work well because the weight of MSW is much higher than the waste in Japan or in Germany. So it cannot will combustion, but we modify the design of the grid is one thing. The second is we develop the own operation method, such like maybe you lose this. In China, we will store the MSW in a tipping hole 1 week. That means after the waste come to the plant, we not how to say immediately burn it. We will store it 7 days. Then the moisture will reduce, will ferment. So the moisture can reduce from 60% to 40%. For 40%, so we will burn it. Is one is the second. The third is we also install gasoline. If the combustion is worse, then we will inject the gasoline to support the combustion. For the CFB and the earlier stage, maybe 20 years ago, we will mix coal, but now we don't necessarily. We how to say have more experience, more advanced technology. Then we reduce the coal mixture from 20% to 0. So actually, the next slide I will introduce the technology development, we reduce the coal mixture ratios. And so just conclude, the emission level burn on the grid or emission level, especially the Indonesia West is no problem because the situation is same China and Indonesia. Even I do some sampling in Bandung, the West is better than our our city because Hangzhou also is a rain season very longer, but burning combustion is no problem. 100% of emission level is burned in our city. The second is about the emission. Yeah, actually the emission is no problem. The emission just depend on the investment. If you have money, you can invest all advanced technology to capture acid gas, capture fly ash, capture dioxin is no problem. As the first lecture I show, we all the emission data is online monitor and is open to the public. We have a TV board on the gate of the plant, so all neighborhood citizen can know what's the situation of the emissions. The second is all the data is connected to the web, so all the public can log in the web and touch the the emission. Of course, I have to point out, as I mentioned sometimes, the standard, the emission standard, you cannot set as strict as EU or UN. So we should, how to say, based on our situation, then we set suitable standard. So now Chinese standard is close to EU, or the factory operation is better than EU. But actually, my conclusion is emission control is no problem. It just depends on how much money you have. If you have money, you set more, how to say, pollution control defense. So for emission, it's not about the technology, just about the money. But for grid, it's about the technology. This is my conclusion. I hope I answer your question, Professor Harry.
Yeah.
Why you smell?
Thank you.
You agree, right?
Yeah,
Thank you.
Yes, yes, I smell. As much as we have a money, then everything we can do, yeah. But
Yeah.
my question, what is the minimum money do we need to have the good emission, but not real answer? No, later on. I think Mr. Soleh and Prof. Mian may communicate again, not in this classroom, because I like to give more opportunity for other person to give answer. Pak Soleh, nanti please you ask in using our private communication with Professor Mian. Yang lain?
Thank you, Pak.
Before the question, I wanted to say hello to Professor Eddie. Professor Eddie, how are you?
Yes. Yeah, we have Professor Adi, and also we have our friend from Thailand, EKK, also here, and also some guests, distinguished guests. So please, question and answer. One more question, maybe. No? From yeah.
Just
go
small
on.
questions. Yeah.
Yeah.
Hi, Prof. Mian. Nice to see you.
Yeah, nice to see you.
Yes, we are always sometimes communication through email, right? Or
WeChat.
Yeah.
Yes.
WeChat.
Okay. It is nice to hear you that is some design already done, and that is sometimes when I visited before to some incinerator in China, I'm always wondering about the design. As I see you from your presentation, there are sometimes many types of design that maybe trying to overcome the problems, I think. Now, my short question is, how about to minimize the corrosion, since the coal burning or feeding the coal to the incineration process sometimes created some corrosion. What do you think to overcome the corrosion?
Okay, Professor Adi, thank you for your question. It's a very professional question. How to say? Based on my experience and my knowledge, we have to set these 2 or 3 points. The first point, that's why for the MSW incinerator, the temperature cannot as high as coal. So because the corrosion. So usually the steam parameter is 450 or 400 to 450, and the pressure maybe we can higher, but the temperature we cannot increase anymore. It will worse the corrosion. So we have set reasonable temperature of the steam. So that because the steam temperature will influenced by the heat exchanger, because corrosion usually happen in the surface of the heat exchanger. So we have to set a reasonable temperature. The second is we have to frequently to blow or clean the ash. We can such like we frequently blow, use steam or use air to blow out the ash. We cannot let the ash stay on the surface of the heat exchanger. So we use the membrane heat exchanger to exchange the convection heat exchanger. This is the second. The third is we should use wheel material of the heat exchanger, especially for the air preheater, because the temperature is lower, it will happen condensation of the acid. So for the primary air heater, we have to use some special material for such like I forget the name. Oh, hold on. What was the name? Yeah, maybe in later slides I will show the name of the material for the preheater. So this is my experience of the third. Of course, now in China, as the last lecture I mentioned, we also do some mechanical sorting to reduce some acid command, or we improve the quality of the feedstock. So it also will helpful for the anti-corrosion. So anti-corrosion is the problem. Usually, why we need to maintain some the main excuse, including block, because the MSW will block the grid. The second is corrosion and exposure of the tube. So corrosion is a problem, but this is under control. We just exchange the tube or some part in schedule, such like 3 months or 1 year later, we exchange. 1 year later, we exchange. So we should will maintain for all the equipment, and we know which part is easy happen corrosion. So this is the case for your question. I hope.
Okay.
Yeah.
Thank you very much, Prof. Mian, for your explaining. Thank you very much.
So I continue my presentation.
Yes, Prof. Mian. I think you will give a lecture about the emission control.
Yes. I think yes.
This Thursday.
Yes. You can go back to the arrangement, right? I think yes. This time is the third, right? Third.
Yeah,
I think fifth. Fifth. I will.
Okay.
Next is calculation. After calculation is pollution. After pollution is dioxin, right? I think like this.
So, Pak Pak Soleh and all of my friends, please follow the lecture as we always put the schedule in our poster or in our leaflet to we distribute to you. Prof. Mianso, please go on, continue with your lecture. Yeah, thank you very much.
Wait. So can you watch my slides? Okay, so I continue. I just finished the grid incinerator. I will introduce CF incinerator. CFB actually, before MSW applied in MSW, usually you applied in biomass. So biomass incinerator widely use CFB, but MSW is widely used grid. Why China develop CFB incinerator? There are two reasons. Okay, I search the CFB incinerator. Why China develop CFB incinerator? First, yes, the grid is expensive at the beginning because China don't have the ability to manufacture grid, so we have to import. If we import, the price is very high. So we want to reduce the cost. The second, this is the first reason. The second reason is because the grid cannot well burn Chinese waste at the beginnings. So we should develop the technology suitable for Chinese waste. So this is the reason why we develop CFB by ourselves. So this is the CFB incinerator system. For the emission control is same, just the incineration is different. You can watch here have 2 feet hoop, right? Because the Chinese MSW, the heat value is lower, high moisture, and is difficulty to burn it. So at the earlier stage, we use coal and MSW mixed together to burn it. Of course, now we don't need it, just at the earlier stage. And this is the CFB structure. So here is the bed. So with cooling distribution board, this is the ignition, and the preliminary air from here, and this is the window of the feeder of the west, and this is the furnace, and the membrane heat exchanger, and this is cyclone. In the grid, we don't have cyclone. Only in the CFB have cyclone. Cyclone just used for catch big particles of the ash. So the ash will come back. This is a loop seal, so make cycles. So the ash come back, then the flue gas go out for heat exchangers. So this is evaporation equipment. This is for primary air. So this is for superheat, and primary air preheat and economizer. And this just introduce the hot bed material is blown by air. So this is hot material, sand or some reduced materials. So very hot. As is blown by air, so air is from bottom. West high temperature bed material and combustion air are fully mixed. So the turbulence is very good. Mix the air, mix the MSW, mix the coal, then can will or how to say combustion. And the fuel has a wide adaptabilities. So because yes, can mix well, and also we can mix coal and MSW. So the heat value change is not a significant influence the incineration in CFB. The capacity itself is higher. So you just add some percentage to new fuels to the furnace. So this is an advantage of CFB. And in China, the development, or we call grid upgrade incineration technology. As first, begin or at the beginning, we use medium temperature separation, means cyclone, and the second we increase the high temperature separation, and after that we high temperature separation and reduce the coal, and after that we research how low emission type of pure burning waste. So just means pure MSWs. So this is the development stage. So first, this is the how to say, the earlier or the first style of CFB developed by China. By China. So cyclone is here. We just use the low temperature separation cycle. How to say, cyclones and low hierarchical separation ratios, such like what means separation cycles means they have a parameter how much material come back and how much material input. So they have ratios. Usually now we can up to 10 or 15 15s. So this is the first version of CFV. What? Okay, so use the first type of CFB, we realize the incineration by domestic technology. After we develop domestic technology, the price of grid will reduce, so we can save the cost and achieve the clean and efficient combustion of MSW. Of course, we realize there are some problem we still need to to resolve. The first is operation of superheater and tubes, and we also need reduce the coal mixture. So at the earlier stage, we should mix a large amount of coal. So it's not good. We have to improve, make some modification and improvement. So the second style of the CFB, we call it high temperature separation. So the cyclone is put before the heat exchanger. Actually, what's the difficulty from the first to second style? Because if you put here, the temperature is very higher, even yes 8 or 1000 centigrade. So your technology, your material of the cyclone should be advanced, should be improved. So this we overcome these challenges. So we use a high temperature cyclone, and the cycle ratio, or we call it as separation cycle, is also increased. So it will make the combustion more stable, and we infect high temperature and low temperature superheater. So here we arrange the heat exchangers, and we use the loop seal. So here is a loop seal. By this modification, we can increase the adaptability to the fluctuation of MSW. So even MSW changing frequently is no problem. But in the CFB, and we can realize large scale waste deposition and complete compensations. Of course, based on this second stage, we know the new problem, or we recognize the space for improvement. Right? Means China control the coal consumption, so we have to continue to reduce the lower blending of coal ratios. So how we do this? Yes, we add more heat exchanger, especially for economics and primary air heaters in the end of the channel. So end flue at a close of heat exchanger will recover the heat and will helpful reduce the coal input or coal ratios. So another is we use larger slug of output design because we have still some pipe, some metal pipes in the MSBL is easily to block the output of the slug. So we have used the large slug output designs, and we increase the convective heat surface to evaporate the waters. So as this modification, we can reduce the coal mixture ratio to less 20%. So this is a requirement by the government, and we can increase the steam temperature increase, so meet the higher level of boiler operations. And of course, we based on the third stage, we understand we still have space for improvement. So this is requirement for quality of waste and cost. So due to the increase in amount of waste, the condition of incinerated flue gas are even worse because the scale become larger. Then we meet the flue gas, the emission become worse. So we have to thinking how to reduce the dust, how to empty the corrosions. So later I will discuss the detail. So in the process of the development of fluidized bed incinerator, the development direction as this. We first gradually reduce the amount of fuel and improve the level of energy savings. The second is optimize the combustion organization and reduce the emission of the second pollutant in the waste incinerating boiler, CO, NOx, dioxin, and to further improve the safety and reliability of the boiler and continuous operation ability. As I mentioned, for the grid, the continuous operation hour 1 year can up to 8,000, or some years ago is 7,200. But for CFB, usually is 6,400. So it's less than grid. So gradually improve the single boiler combustion process capacity, aiming at the development of largest capacity. At the beginning, the capacity only 150 tons per day, but now can up to 1,500 tons per day for one CFB incinerator. So the capacity actually increased very significantly, but of course, step by step, in the last 2 decades, over 20 years. So the structure of CFB, we have the flue gas system is here, right? So the incineration, and we have the air system. So this is the first primary air and the second air. So for the follow chart of combustion, so this is core, this is MSW. So we feed both to the furnace, and this is the slug output. This is the primary air, burn it. The dust will capture, come back, loot here, and this also to cool down the loop. So the system comprises of furnace, material separation, collection, and material return. So just this is the CFB combustion systems. And the flue gas system, actually this is very similar as the vertical grid system. So flue gas leave the cyclone, so leave the cyclone, go to the heat exchange area to produce steam. So the high temperature flue gas is discharged out of the furnace with the induced draft fan of the combustion. The flue gas flow into the heat exchange after most of the particles are spread by the cyclone spreader. So this is cyclone. And this is the air system. So air system have primary air and secondary air. For as mentioned, in the grid, usually we don't need to heat the secondary air, but for CFB, we use the secondary air heater. So primary air is the lead one heat in invert, and even before the superheater, so the temperature of primary air is higher than the secondary air. The boiler uses the grading or section feeding system of air. The ratio of the primary air and the secondary air is roughly 55 to 45. The main point for the key design of a CFE boiler, first is how to ensure the ignition of waste. That means we should burn it and maintain the high temperature of the boiler. As mentioned, in the standard regulation, we have to make the flue gas stay over more than 2 seconds over 850 centigrade. The second is how to ensure the burnout of the waste and to meet the pollutant discharge standard, because the emission actually is related to incomplete combustion, but ICP. So it is very important. And another is what means ensure the burnout of the waste. That means the ignition loss of the slug should be less than 5% for the standard. Usually the factor will set the target is 3%. And the third is how to ensure the stable combustion in different seasons, because the waste will seasonally varied. Winter, summer, and autumn is different, right? Especially in summer, is difficulty to operation as many watermelon tails in the west. And the fourth is how to ensure the closing. Yes, as Professor Adi asked, and should deposit of the heat surface on the harsh environment. So we can divide the key design of boiler into 7 point: high combustion air temperature, design of the combustion chamber, arrange of the water cool developer flue, and feed and fluidized of waste, following provision of conventional heating service, closing provision, and adoption to the change of the waste. So we use the high temperature air or high temperature primary air to make ignite the waste, and we make the furnace temperature is high enough, over 850 centigrade, stay 2 seconds. So the temperature of primary air is very important to ensure the combustion temperature, which is also prerequisite for the clean and efficient operation of the furnace. So here you can see the primary air temperature increase, the furnace temperature also can increase. So 250, the furnace is 800. Of course, the low MSW heat value is lower, only 950 kcal per kilogram. Now, the low MSW in China roughly is 1,500. Is improved significant. And another, in the last class I mentioned, heat value of raw waste, heat value of feed waste is different. After we store 7 days in a tipping hole, the raw heat value can increase from 1,500 to 2,000 kcal per kilogram. That means the quality of waste is well improved. So for the design, now in China, usually use 1,800 kcal per kilogram to 2,000 kcal per kilogram. Not use this one. This one is maybe at the earlier stage. So the technology, the experience is developed. And this is how to realize high temperature primary air. So we set the primary air preheater in front of the superheaters even, right? Or in front of the low temperature superheaters. So it will ensure the primary air temperature is very higher. So primary air preheat, the high temperature air preheater is set up in front of the superheater. The temperature of primary air can be up to 350 centigrade. So it's enough to ensure the combustion is stable, the temperature is higher. So, and in the tail or in the end of air preheater, the primary air and the secondary air preheater are arranged in close with the economizer to improve the hot air temperatures. So including primary air and the secondary air, the temperature is higher, much higher compared to grid. Grid usually is, in China, is 180 centigrade to 250, but for the CFB, usually is 300. So design of the combustion chamber. So the chamber means the furnace. Because the waste is very high content of moisture and low heat value, so the combustion heat should be used for the water separation. And during in the furnace, we will cover with the reflector and wear resistant casting material to reduce the heat absorption in the furnace. So it will help for keeping the combustion area temperature is higher. So we combust it first, then we absorb or exchange the heat. So it should be partly covered with the reflector and wear resistant casting material to ensure the temperature higher than 850 centigrade. So this just like reduce the heat exchanger in the furnace to ensure the temperature. And the specific design of the second air outlet position and the distribution shall be coordinated with the character of the waste and the position of the waste feeders. So where inject the second air is very important. So this is arrangement of the evaporative flow channel. So the heat exchangers. The furnace radiation evaporating heating surface are basically covered with the refractory material. So in the furnace, we reduce the heat exchanger. We hope the heat exchange happen here, so it can be increase the incineration or oxidation reaction times. So 3T plus O, time, temperature, turbulence, and oxygen. So we use the heat exchanger instead in the behind will increase the reaction temperature and reduce the CO. So because here before this we don't use any the heat exchanger, such like for coal power plant we will use the water wall, right? The water membrane walls. But usually here we don't use. In WTE we don't use. So excuse me, this is primary air, and this is a superheater. So this is the flue gas channel. So this is the first, this is the second flue gas channel. And feed and flow diet of MSW and discharge of the slag. More feeding point of waste should be arranged, so the mixture will homogeneous, and the size of the feed should be enlarged because the waste has high content of waste and the size is sometimes big, or the composition is complex, even with some large particles. So here we should be larger, and the heat of the feeder and the air distribution plate should be able to avoid the force flow of the flue gas, because we have to avoid the flue gas go out through the feeder, right? So usually the feeder output is under the dense levels. So means how to say the waste is directly mixed to the sand in the bed, not on how to on the over of the fires. And we use the larger slug discharge. So this is the blow height. So the AI is blow to the bed through these patterns, so different kind. And here we use larger, so 400 millimeter to 600 millimeter. So that means the slug can smoothly discharge. Otherwise, block here, then it will, how to say, have to stop it and to open this discharger. So this for the CFB, the main problem is two. The first block the feeder, the second is block the slug output. So sometimes we have to use some tube to make it how to say slow. So it is needed frequently in the earlier stage, but now it's much better. We use a larger discharge output. And we how to prevent falling of convection heat surface. So memory type what called evaporate channel replaced the convection evaporate tube. So at the beginning we use this kind, use convection tube. Right? Now we must use this membrane type what called evaporate. So it will be how to say reduce the falling and the ash stick to the surface. And the super large space of evaporable tube. So we for the core, the membrane wall is the tube almost connected together, right? Fairly small, but for the MSW, the space is larger. And the soot flow are arranged reasonable or frequently. The flow dust is separated by graphite with the design of the double flow channel to the hoop to reduce the connection of ash. What means this? I think I can come back a little. Yeah, here. So the flow gas coming through this part. Here just like another cycle, right? So the ash also can separate by this hoop. About the closing, so the temperature and the inlet of superheater should be lower than 700 to decrease the temperature of the tube wall. Of course, if the lower 700, your steam temperature, superheated temperature is it cannot be higher. So yes, 450 centigrade usually. The type of material of a high temperature superheater is TP347H. So this type of the material, and the temperature of steam should be about or less 450 centigrades. And the air preheater is in hierarchical arrangement, and the porcelain image. So this is the material, right? In the mill. So just like crystal or just like glass type is used to prevent the low temperature closings. So let me make record in the mode and improve the adaptability of boiler for MSW. So add a short circuit bypass around primary air preheater. What it means? Because we usually the primary air heater, after heating, it will mix with some refreshing air, then adjust the temperature. But in case the temperature is lower, so we directly use the hot primary air to the furnace. So this is a bypass. And we use more superheated area to ensure the steam temperature. And we use evaporate channel surface to ensure the production means how much ton of steam should be produced by this boiler. And this is some industrial applications. So over the last 20 years, more than 120 CFB incinerator was installed in China. Of course, the market ratio is decreased. And maybe 10 or 15 years ago, the market CFB to grid is half to half. So they share the market. But now the market of CFB only is 25 percentages. We have developed the different skill or capacity CFB. Now the largest is 1,500 tons per day. This is a case of CFB. So this is the steam evaporation rate, 45 tons per hour. Temperature is 485, and the steam pressure is 5.3. Feed water is 150. And the design waste still is lower because it is the old one. And the capacity is 800 tons per day. The heat efficiency is 78, and the primary air ratio is 40%. As mentioned, there is 50 to 55 primary air, right? And the second, the primary second air is 380 or 350. It's much higher than the grid. The flue gas is 165. So this flue gas temperature is lower compared to the grid. Means more heat is recovered from the flue gas. And the circulation ratio or cycle ratio is 10. 10 to 15 mean what it means here? So it means the material captured by the cyclone, the amount in 1 hour over the amount of feeder is 10. So this is some case of CFV Zibo is 4,000 tons per day, and Wenling in our province 1,060 tons per day, and Gaomi all these plant I visited is 800. Wenling is another one is 1,000 tons per day. So this is the DCS of the CFB. The inside is vacuum, so the flue gas will not go out. So the temperature can 900. The output is 906 centigrade. And this is another one CFB. So the pressure inside of the furnace is negative 254. So then the vacuum is higher than the grid furnace. The grid furnace usually is negative 30 or 40 par, but for CFB is over negative 200. Of course, the emission is very low. The CO only 1.1 mg per cubic meter. And the last is some words from my personal. Good result or good performance is dependent on the technology, dependent on the manufacturer, also dependent on the operations. Operation is very important, so you have to train your staff. The second is I wanted to say non-technology is perfect, and all the technology will develop step by step, and it is hard to judge which one is best. You had better choose suitable one. Suitable means or fees should be proper to your MSW, your budget, your labor skill, your business model, right? And also suitable is varied with time, because with time your MSW changed, your budget changed, your skill changed. So suitable is important and suitable is varied. And before your decision, please walk around, have a look around, have a look by yourself, listen to more users' feedback, because always the technology supplier or the equipment supplier will tell you all the advantage, all the good performance. They will not tell you what's the problem of their technology. So such like when you buy a car, you make a decision. Usually like this, you will thinking your income, right? What's the usage of your car? So of course, maybe everyone want to buy a basic car, but if you want to buy a car for transporter or for logistic, maybe you should choose this one. Or yeah, it depends. So make a decision, just comprehensive, consider your situation. That's my personal words. Like, oh, thank you. So now is how to say open question time.
Thank you very much. Yes, another time for question and answer. I I open the question and answer. Please raise hand or just say if you want to speak, if you want to give your question. Silakan Bapak-Bapak sekalian kalau masih ada yang ingin disampaikan. Prof. Mian, may
Yes.
you stop your sharing and I like to share the poster just to remind the audience.
Okay, I already stopped.
Yeah. While waiting for the question from audience, I like to present the schedule for this week. Now and next Thursday, we still talk about the waste incineration technology for incineration. And after this, we will meet again in the mid of October, 11 and 14, and then the end of October with another topic. Yeah. We will distribute again time by time. Last time we already passed the topic of development of waste to energy in China and waste sampling and its properties analysis. Okay, that's my announcement. So please attend the next lecture. So, any other question from audience, student or distinguished guest? Ada Pak Ali dari Pusri atau Pupuk Indonesia, ada Pak Arti dari Agro Abis Palacio, Eka from EKK from Thailand, Sajid from Pakistan. If you have any question, please.
I will share all my slides
Yes.
to Professor Harry. If you need it, you can request from Professor Harry. Yeah, the last two presentation slides already share. So this one I will share. I already sent it to Dr. Dewey. Maybe he can share if you send an email or how to request.
Well, Prof. Mian.
Yes.
What is this program? If you use the schedule on Thursday mostly for question and answer, and after we distribute the material from you, and then we hope the audience, the student can learn, can examine the material, and then give the question on Thursday. What about that? And so the Thursday, we open first the question and answer. Then after that, if the time is still available, you continue with your material. What about that?
Of course, no problem. Maybe
No problem.
before my each presentation, we ask, do you have questions about the last presentation?
Yeah. Because this is the lecture I usually use. Yeah, I
Okay,
usually
lecture.
use that. Yeah, after explanation, and then I give the material. Then the student learn about that, and then in the next lecture, I open the question first. What about that? It's good. So, para peserta sekalian, terutama para mahasiswa, nanti ini dipelajari. Saya kira slide pertama, slide kedua, dan slide hari ini yang ketiga akan diedarkan, atau kalau belum mendapatkan minta saja ke ini Dwi Handoko atau Aisyah Ardi, atau Dwi dan Aisyah akan menaruhnya di mana itu. Dwi dan Aisyah salah satu menuliskan di mana mereka bisa mengunduh material ini. Prof Mian, I just say to audience that your material will be uploaded to a place where the audience can download it.
Yeah, Professor, I think one person want to ask a question. Mr.
Okay. Oh, sorry.
Wiono.
Yeah.
Mr. Soleh also. Mr. Soleh
please.
also want to ask some questions.
Yeah. So my announcement is stop, and then I let Professor Mian to answer, and also maybe also use your slide, Prof Mian. Go on, please. Siapa itu? Silakan. Siapa? Saya nggak bisa melihat. Apri Wiono?
Iya.
Oke, terima kasih.
Terima kasih, Pak Heri.
Habis itu siapa? Ada satu lagi? Pak Soleh lagi?
Ya, kalau boleh Pak. Terakhirnya.
Sorry.
Bismillahirrahmanirrahim. Terima kasih Pak Heri, Pak Soleh, dan rekan-rekan sekalian yang hadir. Good afternoon, Prof Mian. Nice to meet you.
Me too.
Yes. Thanks for your good presentation. I wanna ask 2 questions, if you want. First, based on your presentation, you mentioned some types of grade like vertical, horizontal, and etc. But I asked you mentioned the multi-stage of grade. May I know the function of multi-stage of grade? Is it for heating efficiency or emission or other function? That's first. And second question, I wanna ask about CFB mechanism. As I know about the CFB mechanism, there are feedstock must be circulate or fluidize the feedstock, as I know. Can you explain the mechanism of CFB for different density? As you mentioned, the feedstock can mix like coal, biomass, or plastic. May you explain the mechanism of CFB? Yes, I think that's it. Thank you, Prof Mian.
Okay.
Before the answer from Prof Mian, may Pak Apri introduce yourself shortly.
Oh yeah. I'm sorry.
Prof Mian.
Pardon me, Prof Mian. My name is Apri Wiono. Can you say Apri for me? I am from Universitas Pendidikan Indonesia in Bandung. Thank you. Mohon maaf, Prof Heri.
Yeah. Okay, Prof Mian, please answer this question, and then Pak Soleh after this.
Okay, thank you for your participation, and you're welcome. Nice to meet you, Mr. ably. So for your question, the first question actually, the function of the different kind grid just for mixture, just how to use different style to mix the MSW, the hot MSW and the cool MSW. So maybe I can share again the slides. Okay, hold on. Wait.
Yes, it's still going.
You see, right? Going, right?
Now, right.
Okay. How about now?
Yes, now.
Okay, wait, I go to.
We can see that.
Okay, wait, I go to the slides. So actually, never mind what kind, how to say, the voice, horizontal or the rotary, or we have another one is vibrating. Just try and use different method to mix the MSW. So from here, actually the surface is flame, is burned, but the bottom is refresh or is dried MSW. So we have to mix it. Make the bottom MSW go to the top go to the bottom. So we'll mix the burned MSW and unburned MSW. Then it will helpful for combustion. So the movement is for the combustion efficiency. So this is the function. Of course, different company, they use different method. All the method can mix, but how to say, maybe the efficiency is different. And of course, the mechanism is mechanism. The real performance depends on the design. So if you use the horizontal, okay, the mixture can also be good. And why we use now more use the reverse style, because it can save the air and can increase the time of the resistance time of MSW on the bed of the grid. Because if you have to just the forward, the MSW will quickly move and quickly leave the grid. But in order to ensure the enough resistance time to completely burn it, so we have to increase the length of the insulator of the grid. So now the first is more commonly used. So this is the function. Maybe you also mentioned about another horizontal style. Yes, it means for the heat exchanger. So for the heat exchanger horizontal arrangement, of course, this is for excuse me, here. Here actually, what's the reason? Two. First is we want to increase the heat exchanger efficiency. The second is we want to reduce the ash, because such like this, the falling will be easy. The ash will easily to block the heat exchanger, but this one, maybe the ash will drop down by graphite. So this will be easy to clean the ash on the surface of the exchanger. For this one, we add another close of the channel is for increase the thermal efficiency to recover more energy. So this is the first question. About the second question, we can see this slides. Excuse me. The mechanism of CFB. Excuse me. No, this one.
Please shorten, Prof. Mian, because we still have one more person to ask.
Okay, so let me finish the question. Okay, here. So this, the right side, show you the mechanism. So how to say, actually, because in the inside of the CFB, the material will mix together. So for coal, you feed MSW feed, so the material can mix it themselves in the space. So this is much better compared to the grit. The grit, if you mix or just feed the coal to the grit, it cannot be well mixed. So usually for the grit, don't use coal to support the combustion, use gasoline. So maybe some position gasoline burner to increase the temperature and the earlier stage. But for the CFV, can will mix the coal and MSW together. So this is the mechanism of CFB, and this is the second air, secondary air, and the first or primary air, and the cyclone. So this is cyclone. The ash, the particle will come back. So the sand come back. Then the bed is very hot. So when your low heat value, MSW drop down, then can heat by the sand, then combust. So this will be more helpful to ignite the low or worse quality of MSW. So this is my answer to your question. Hope I already explained your question.
Yeah,
Okay, thank you so much for the answer, Prof. Ian.
Pak Ari, you can ask again next time, maybe next Thursday. Pak Saleh, go.
Yeah, Pak.
Please.
Thank you, Pak. Yeah, very interesting, Pak, for the last part using the CFB as MSW incinerator. Yeah. This is so, Pak. There are two questions. First is as far as I know that CFB using a fluidized bed, we mix with some kind of sand or fluidized materials, and then the materials, the fuel, is mixed in there and then keep floating. Yeah, keep floating while by being burned, and then the combustion occurs in the bed. Yeah, and then the heat transfer through the heat exchangers of the boilers. First question is how I'm still not getting the. We have trouble in my experience in a power plant that we have to maintain the size of the materials to be uniform, to maintain the air from the below, yeah, to maintain the fluidized size. Yeah, fluidized size is maintained is a certain height, and then if there is change of sizing, and then the air will be too fast, and then the fluidized will be too high, and then will reach the heat exchanger. So the combustion must occur in the the furnace, yeah, which is lined with the refractory stone, yeah. And how would you maintain that with the ununiform form of the MSW? That's the first question. And then the second, I saw that the configuration is a little bit different. So in the coal power plant, the furnace, and then after the furnace, there will be evaporator, and then transfer from up and to bottom. There will be a superheater, and then in the last section is the economizer. So I saw that it's a bit different, the configuration. That's very interesting to me. And then you mentioned also that's that formation, that configuration is to prevent the falling, yeah, because you said there will be like a hopper in the bottom, and then after that there will be another heat exchanger, and then the gas will flow to the upper section. That's very interesting. Could you elaborate more about that?
Okay.
Thank you.
Thank you for your questions. Yes, about the CFB, there are many technology, many patent. So we need to do some experiment before we design the CFB. About the size of the sand. Actually, usually we recycle the slag. The slag. We recycle the slag because then we screen it. Some size is meet our requirement, then we feed back. So we will feed back a slag to the CFB for the reduced material. So usually we don't need how to say to buy or add more sand. It's because the sand is from the slag. Slag is from the MSW. So we just recycle use. So this is the size. And another, maybe you mentioned about the change of MSW. Why CFB can suitable or adaptable for the change of MSW? Because in the furnace, in the CFB, there are a lot of sand, and the sand is very hot. So when you the CFB, the MSW coming, even your heat is lower than the sand half. So you just add some MSW into the sand and use the sand heat to dry the MSW first. So then, they will how to make the immediate or short time MSW feeding or heat feeding is not very important for the whole system, because such like I already have many money, then you give me 10 or 8 RMB, it doesn't matter. Such like I have 1,000 RMB or 1,000 USD, then you say, oh, you give me $9 or $10. For me, it's okay, not a significant difference for me. So it is the same reasons, because the sand is a fairly amount, such like the cycling ratio is 10 or 15. That means the sand cycle 10 times for of the MSW feeder. So this is the first question. About the second question, I can show again the slides.
Yeah, slide is still screen.
Okay, wait. Oh, sorry. Yeah, I think we can use
this one, but yeah.
So you are right. You are very familiar with coal power plant. This is the reason why we design like this. Two reasons. First, this if we say this is chamber, this is the first flow channel. So we actually is like this. The flow gas leave the furnace, come here, then go down, then go up. So superheater is here, primary air is here. Two reasons: we can increase the flow channel, so we can increase the resistance time for flow gas. Will be helpful for completely burn the organic component in the flow gas. So this is for longer time combustion and reduce CO, reduce incomplete combustion products. This is first. The second is we have this hoop. So the flue gas have turned around, then the heavy particle will go down, the flue gas, the light gas will go up. So here, use this one, we can separate some ash. The third is, if follow, go this. Of course, the ash will not easy to, to stay in the surface. Such like if the ash, the flue gas go this that direction or go this here, of course, here will be easy, the ash stop on the surface, because the ice drop down, then the surface hold it. So this will be reduce the falling here. And the primary air sitting here because we need a high temperature, 350 centigrade, for the MSW combustion. I think for coal combustion, the primary air is not necessarily so high because we need high primary air temperature to ensure the furnace or the combustion temperature is higher. Otherwise, it's not stable for combustions. So this is the design. It's developed step by step. So as maybe at the beginning, maybe this one. Okay. At least maybe the traditional of coal power plant, right?
Yes.
Coal will be like this. So we technology developed from coal boiler, then we have to modify it according to MSW combustion characters. So we modified it step by step, then this, then like this. So this is the reason.
Yeah. So basically the MSW will have longer time, yeah, longer flame.
Yes, because the particle size is bigger, right? As the power is the coal is power, right? Pulverized power, so it's just like a very small particle. Is easy to burn for coal, but the MSW we need a longer resistance time.
Yes, thank you, Pak. Punten Pak Heri, maaf. Masih penasaran. Makasih Pak, makasih. Thank you.
May I disclose who are you? Pak Soleh? You are the expert from Indonesian Power, that is the national electricity grid. But you are now a student of ITB. Then I think Professor Mian sometime will invite you to have a visit with him in China.
Yeah. Yeah, Pak. Thank you, Pak.
Okay. Okay, I think time is up. It's already 15 minutes past 5, so we have to close the meeting. We have to close the lecture, and we will meet on Thursday, and we will open the lecture on Thursday with the discussion. I'm sorry if someone want to ask, not now. I remember one of my students last time also want to ask, but no time. So we will have more discussion time on Thursday. Prof. Mian, thank you very much for your kind presentation, for your nice presentation. And also from our audience, Pak Ati, if I like to mention, and also my friend from all other place in Indonesia and Thailand and Pakistan, and also in Malaysia also here. Thank you very much again, and we see again on Thursday. Bye bye. Assalamualaikum warahmatullahi wabarakatuh. God bless you and stay healthy.
Recording stopped.
Thank you very much.
Yeah, thank you.
Thank you very much.
Bye bye.
Thank you, Pak.
Good afternoon.
Yeah.
Thank you very much.
Maybe I want to collect the next lecture is October 11, is right? Do it.
Yes. October 11.
Yeah, not next Thursday.
Not Thursday?
Yeah.
Oh, Thursday, no. Okay.
October 11 is Monday.
Not this Thursday?
Yes. Because we are holiday.
Okay.
National holiday.
Yeah. Sorry. Then we will make the announcement. Yeah.
Okay, bye-bye.
Thank you very much.
Bye-bye. See you.
Have a nice day.
Roberto Adi, see you.
Yeah. Semuanya selamat bekerja.